Algebra students, Mr. Lawrence here, and we are going to start learning how to solve other types of equations. We've been working on linear equations, and we're going to learn to start solving some other types. Now, I know most of you have forgotten because you think, well, we don't really use it, so I just kind of forgot about it. But you see, everything we do in here builds to everything else. So we can't forget it. So we'll be reviewing as we go along some important concepts that you should already know. If you don't know them, come on and see me and we'll go over them again. Okay, so first of all, I've got a little chart made up here with the different types of equations, right? A linear equation, for example, a linear equation might look like y equals 3x minus 5. I could put a value in for y and then solve for x, right? That's a linear equation. Its shape is that it makes a line, right? Okay. We don't know what kind of line it's going to make just yet, but for right now we do know it's linear. Remember, we know it's linear because the exponent on x is 1 and the exponent on y is 1. Okay, and again, we could substitute a value in there, but the highest power on the x variable is 1. Okay, now this of course is degree 1, and a linear equation, the maximum number of solutions it can have would be 1. Notice that matches the degree. Now we're assuming that it's not all real numbers, it's not one of those special cases, and we are not assuming that it does have one solution. We're saying the most number of solutions other than all real numbers can be 1. It could have no solution. Okay, it doesn't have to have one. All right, now a quadratic equation, if you recall, quadratics look like this. Y equals, say, x squared minus 5. And remember their shape? Yeah, they made that U shape, that parabola, and the parabola might open upward, might open downward. In this class, I don't believe they're ever going to open left or right. That's a slightly different equation. But for right now, we'll have them open upward and downward. Now, it's degree 2, right? Because it's a second degree right there. And so it's degree 2. And the max number of solutions in a quadratic, if you didn't catch this in class yet, or you didn't get to it in class, depending on how far along your particular period is 2. And it matches, yeah. Now, again, it doesn't mean it's going to have 2 solutions. It might have 2 solutions. It might have 1 solution. It might have no solutions, okay? I'm trying to think of a quadratic that would have all real numbers, and I guess it would have to be something like an x squared equals x squared, right? Something like that, but that's kind of a strange situation. That doesn't really happen in a quadratic as often. It could, but the max number of solutions would be 2. Notice it matches the degree. Doesn't mean there are 2 solutions, but it can have up to 2 solutions. Okay, a cubic would look like this. Y equals x cubed, and of course these can have other things in here. This is still cubic even though it's got an x squared in there because the highest degree is 3, so it's cubic. Now a cubic is going to look something like this, and I don't know if you remember this, but it's just the parabola and part of it's bent down. You see this parabola going in a U shape? Well, if I took this portion of the parabola and made it go downward like that, then I would get the cubic. And we'll talk about that later when we get more into graphing. Okay. So, you see, I guess I wanted that to be blue, so it matched. Properties. Blue, there we go. All right, it is degree 3. Yes, degree 3. And the max number of solutions is 3. Again, it doesn't have to have 3 solutions. It might have 0, 1, 2, but it could have up to 3 solutions. Now, quartic, and we won't do much with actually solving quartics, but a quartic would have something like this. The highest degree is 4. Could have other things in there like that. Okay, a quartic is actually going to look like a parabola, only it's going to climb faster in most cases. And it can also have some funky things going on in here, like In some situations, it might kind of do something like that. Okay, but the overall general shape will be parabolic. It's degree 4, and the max number of solutions, you guessed it, is 4. Again, doesn't mean it has 4 solutions. All right, now we're going to change direction seemingly, but not really here. I want to know what 5 times 0 is. What's that, Allie? Yeah, you're absolutely right. Of course, it's 0. And how about 0 times 12? Jacob, come on, Jacob, you know 0 times 12. Of course, it's 0. And then what's x times 0? I better go with somebody really intelligent on this one. Kiona, what is x times 0? Yes, absolutely, 0. Right? Whenever I multiply a number by 0, I get 0 for an answer. That's very important. Did you hear what I just said? Whenever I multiply any number by 0, I get 0 for an answer. And I'll show you why that's so important in just a minute. Okay, I've got the quantity of x plus 1 times 0. What do you think, Morgan? Are you thinking 0? Yeah, you're pretty smart. Now, let's come down here. I've got 5 times some unknown. That equals 0. Well, Kimberly can tell us that we'd have to plug a 0 in there. Okay, now, I've used a lot of 0. I've done some real simple equations here, solving some of them. But let's check this one out right here. Okay, I've got this quantity, x plus 1, and this quantity, x minus 2. They're being multiplied together, and I've got to get 0 for an answer. Now, some of you might think, hey, I'm going to double distribute. Well, actually, I'm not going to. Okay, I'm not going to double distribute in this case. Remember a couple minutes ago I said that whenever you multiply any number times 0, you get 0 for an answer. Well, here I have 2 numbers being multiplied, and I'm getting 0 for an answer. So one of these must somehow be 0. They don't look like 0. That says x plus 1. That says x minus 2. But one of them must be 0. Otherwise, I couldn't get 0 for an answer. Well, first of all, let's see what kind of equation it is. Let's take the highest power of x, which would be 1, and multiply it by the highest power of x in the other quantity. Well, x times x is x squared, right? Now, I don't know if you can realize this. If I continue to distribute, I'm going to end up with a minus x and a minus 2 equals 0. Now, what kind of equation is this? Well, it's quadratic, right? Remember we just learned that? It's quadratic. And since it's quadratic, the max number of solutions is 2. Okay, that's very interesting. Very interesting. So let's get back to this. One of these quantities must be 0. How do we find out which one it is? Well, let's take the first quantity, x plus 1, set it equal to 0, and solve for x. And we get negative 1. Hey, what happens if I take negative 1 and I substitute it in for x right there? In other words, I take negative 1 plus 1, and then I multiply it by x minus 2. Well, negative 1 plus 1 turns into 0, and 0 times x minus 2, that's going to equal 0, isn't it? Oh, that's pretty crazy. But we're not done. You see, the other quantity might be 0 sometimes. And let's take it, x minus 2, set it equal to 0, solve for x, and we'll get x equals 2. Well, what happens if I plug 2 in for x? Well, that doesn't equal 0, that equals 3. But what if I plug it into this one, 2 minus 2? Oh, I get 3 times 0, which equals 0. So you see, this equation is quadratic, and it actually has 2 solutions. The solutions are x equals negative 1 and x equals 2. The solution set would be negative 1 and 2. Huh. Now, I know you don't totally get this 100% right now, so let's do a couple more examples and see what you can do. All right, the first thing I'm going to do is I'm going to determine what degree equation I'm working with here. So I'm going to find the highest power of x, which is 3x to the first, right? And in the other quantity, it's a 5x to the first. I'm going to multiply them together. And that's going to get me a 15x squared. Now, I'm not going to do the whole rest of the distribution. I know the last one I said I wasn't going to, and I did, but I was just trying to show you. Okay, whatever I get after this, the highest degree is going to be 2. This is quadratic. Since it's quadratic, I'm going to look for 2 solutions. I might not find 2 solutions, but I'm expecting 2 solutions. So, now that I'm expecting 2 solutions, I'm going to take this first quantity, 3x plus 4. I'm going to set it equal to 0. I'm going to solve for x. Just using Saddam. Divide by 3, divide by 3. X is going to equal negative 1 1/3. If I take negative 1 1/3 and I plug it in for x, this quantity will turn to 0. Whatever this quantity is will be multiplied by 0. It will also be 0. Now, I'm going to take the second quantity, the 5x minus 10, set it equal to 0, and I'm going to solve for x. So I'm going to get 5x equals 10, divide by 5, divide by 5, and x is going to equal 2. Hey, look at this. I found my 2 solutions. If I put 2 in here, I get 5 times 2 minus 10. Well, 5 times 2 is 10, minus 10 is 0. This will turn to 0. My solutions are negative 1 2/3. Oh, 1 1/3, excuse me. Sorry about that. Okay, negative 1 1/3 and 2. There are my 2 solutions right there. Okay, let's try this one. Do you see 2 quantities? I do. See that quantity right there? I take each quantity, set it equal to 0. Oh, I guess I should have determined what type of equation it is. Well, I've got x to the first, and at 2x to the first, when I multiply that together, I get 2x squared, right? Because x times x is x squared. So this is quadratic, so I'm looking for 2 solutions. Well, this one was cake. I didn't have to solve. X is already alone. 0 is one of my solutions. Okay, now I'm going to solve this one. I'll get 2x equals negative 1. Divide by 2, divide by 2, and x is going to equal negative 1/2. And there is my other solution. All right, now you might be starting to think, well, they all have 2 solutions. No, they don't. They don't all have 2 solutions. Let's check this one out. Let's find the highest power of x in each quantity. Maybe I should get a highlighter out here. Okay, it looks like in the first quantity it's a plain old x. Second quantity it's a plain old x. And then here I have a 3x. Let's multiply them together. Let's see, there's a 1 there and there's a 1 there. So 1 times 1 is 1 times 3 is 3. X times x times x would be x cubed. So this must be a cubic. And since it's a cubic of degree 3, there are 3 maximum solutions possible. Okay, the maximum number of solutions is 3. It doesn't have to be 3 solutions. Okay, so let's take each quantity. Let's take x plus 5, set it equal to 0. Let's take x minus 7, set it equal to 0. And we'll take 3x minus 10 and set it equal to 0. We'll solve each one of these equations separately, and we'll see how many solutions we end up with. And so for the first quantity, we get x is negative 5. There's one solution. We add 7 on the second, and we get x equals positive 7. That's the second solution. And we're going to add 10. And we'll get 3x equals 10. X is not alone. Divide by 3. X will equal 3 1/3. So my solutions are negative 5, 3 1/3, and 7. There you go. There were 3 solutions. Hey, how many solutions would this have? Let's go 4x cubed minus 1. Oh, can't do that. Sorry. Getting ahead of myself. You guys aren't ready for that. My mistake. Let's go back and recap really quick what we did, and then we'll get to the video quiz. All right. First of all, we noticed that the maximum number of solutions an equation has matches the degree. Okay? Second of all, we learned that to get 0, listen to this, this is very important. You might need to know it in a few minutes here. To get 0 as an answer for multiplication problem, one of the factors must be 0, right? To get 0 as an answer in a multiplication problem, one of the factors must be 0. They could both be 0, but one of them must be. All right? And then we learned how to find the solutions. And the first thing we did was multiply the highest power of x by the highest power of x from each quantity so that we could know the degree. So we knew how many solutions we were looking for. Okay? Then we set each factor or each quantity equal to 0, and then we solved for x listening to Saddam. That told us the number of solutions. Okay, now, what if you had something like this? How about x plus 1 times x plus 1 times 2x minus 6? Okay, I don't know if you can tell yet, but if I multiply x times 2x, I'm going to get 2x cubed. Therefore, this is a cubic, right? Max number of solutions is 3. But we're not going to get 3 distinct solutions on this one. Watch what's going to happen. I'm going to take x plus 1 equals 0. I'm going to subtract 1 from both sides. I get x equals -1. There's one solution. But when I do this one, I'm going to get the same exact thing, aren't I? So you see, I'm not getting a new solution. I'm only getting the same one twice. Now when I do this one, I'm going to add 6 to both sides, and I'll get 2x equals 6 divided by 2, and x will equal 3. So you see this one only has 2 distinct solutions, -1 and +3. Okay, so that's a case where we don't always get the same number of solutions as the degree. We couldn't get 4 solutions because it's only degree 3, but we can get 3, 2, 1, or possibly no solution. All right, so here's your video quiz, and actually I think there are 3 questions here. So the first question is, what is the only way to get 0 as an answer when using multiplication? And I just said that a couple minutes ago, so you can rewind if you didn't get it. How can you tell the maximum number of solutions an equation can have? All right, well, that should be pretty easy. And then what is the degree of the following equation? All right, this should be pretty easy to do. Also, I'll give you a hint. 1, 2, 2, 2. Multiply those together and you should know. All right, that's it for the video. Mr. Laurence signing off. Have a good night, everybody.